Hello GATE aspirants, welcome to part 13 of GATE Atomic and Molecular Physics series. Question number 14. An excited state of calcium atom is Mg2p5 4s/3d1. The spectroscopic terms corresponding to the total orbital angular momentum are. Here 4s2 is completely filled and we have 3p5 here and 3d1. Now here L1 is equal to 1 and here L2 is equal to 2. So L will be L1 minus L2 to L1 plus L2. So this will be 1, 2, 3. So that means these are P, D and F. So answer is B. Next question. For normal Zeeman lines observed parallel and perpendicular to the magnetic field applied to an atom, which of the following statements are true? Now sigma and pi lines where perpendicular to the field are plane polarized. So if they are perpendicular, then they are plane polarized. So sigma lines perpendicular to the field are plane polarized and pi lines perpendicular to the field are plane polarized. So this is correct. And sigma lines which are parallel to the field, only those are visible, and pi lines are not visible parallel to the field. So here option D is correct. So only sigma lines are observed parallel to the field. So here option B, C and D are correct. Next question. In a solid, a Raman line observed at 300 centimeter inverse has intensity of Stokes line 4 times that of anti-Stokes lines. The temperature of the sample is. Now intensity of Stokes line upon intensity of anti-Stokes line is equal to E raised to h nu by kT. Now nu is equal to C by lambda, or 1 by lambda is wave number, so nu bar. So, and this can be written as ln of Is upon Ias is equal to h nu by kT, and this is ln of 4 is equal to h nu is C into nu bar upon kT. So T is equal to hc nu bar upon k ln of 4. Now value of h is 6.63 into 10 to the power minus 34 into C is 3 into 10 raised to 8. Then this is 30 centimeter inverse. So 30 into 10 to the power 2 meter inverse upon value of k is 1.38 into 10 to the power minus 23 is equal into, we have ln of 4. So if we substitute all these values and calculate for T, then T is equal to 311.9 Kelvin, and if you want to round it off, then this will be 312 K. So answer is 312, and answer given in the answer key is 3112 312. Next question. An electromagnetic pulse has a pulse width of 10 raised to minus 3 second. The uncertainty in the momentum of the corresponding photon is of the order of 10 to the power minus n kg meter per second, where n is an integer. The value of n is. Now we know delta t is given here minus 3 second, and delta E into delta t by Heisenberg uncertainty principle, this is h cut by 2, and delta P is equal to delta E by C. So that means delta P is equal to delta E will be h cut by 2 delta P. So this is h cut by 2C delta T. H cut is 1.05 into 10 to the power minus 34, 2 into 3 into 10 raised to 8. Into delta T is 10 to the power minus 3. So from here delta P is equal to 1.75 into 10 to the power 4t. So n is equal to 4t, and answer given in the answer key is 39 to 40. Next question 35. A spectrometer is used to detect plasma oscillations in a sample. The spectrometer can work in the range of 3 into 10 raised to 12 to 30 into 10 raised to 12 radian per second. The minimum carrier concentration that can be detected by using the spectrometer is n into 10 raised to 21 per meter cube. The value of n is, now omega p is equal to under root of Ne square upon m epsilon naught, where n is the concentration. So from here we can write n is equal to m epsilon naught into omega p square upon e square. So n is equal to m mass, so 9.1 into 10 to the power 9, mass of electron only, so 9.1 into 10 to the power minus 31 into epsilon naught is 8.85 into 10 to the power minus 12 into omega is here 3 into 10 to the power 12. Minimum we have to calculate, so we will consider minimum value, and its square will be 3 square is 9, 10 raised to 12 into 2, that is 24 upon e square, that is 1.6 into 10 to the power minus 19 square. From here n is equal to 2.83 into 10 to the power 21 per meter cube. So its value is 2.83. Answer is 2.83. And answer given in the answer key is 2.70 to 2.96. Next question. A diatomic molecule of mass m, electronic, rotational and vibrational energy scales are of magnitude EE, ER and EV respectively. The spring constant for the vibrational energy is determined by EE. Then the electron, if the electron mass is m, then we have to find relation between these energy levels. Now ER is equal to h cut square upon I. If I consider lowest possible case, then it will be h cut square upon 2I into j is a plus 1, but I am considering j is equal to 1. So 1 into 2 by 2, so 1. And this will be h cut square, I is mr square. So that means it is inversely proportional to mass. So ER will be a for mass of nucleus and mass of that molecule upon mass of electron into will have EE. So here option A is correct because it is inversely proportional to mass. Next is EV, that is h cut omega. Again we are considering lowest possible case. So then this will be h cut into omega is under root k by m. So that means it is inversely proportional to square root of mass. So EV will be proportional to square root of m by m into EE. So here option C is correct. Next question. Frequency bandwidth delta nu of a gas laser of frequency nu hertz is, delta nu is 2 nu by C under root alpha by A, where alpha is given at room temperature and A is the atomic mass of the lasing atom. For 4He20Ne laser, wavelength is 633 nanometer and delta nu is n into 10 to the power 9 hertz. The value of n is. Now for helium neon laser, the lasing atom is neon. So delta nu is equal to 2 nu by C upon under root alpha by A is equal to, but here value of lambda is given to us. Now C by nu is lambda, so 2 by lambda under root alpha by A. So this is equal to 2 upon lambda is 633 into 10 to the power minus 9 under root alpha is 3.44 into 10 to the power 6 upon A, that is for neon, which is 20. Now this comes out to be 1.310 into 10 to the power 9 hertz. So answer, rounding off to one decimal place, it will be 1.3 into 10 to the power 9 hertz. And answer given in the answer key is 1.2 to 1.4. So these were all the questions from GATE 2022 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.